Here's my analysis of problem number 1. What I see first is that 4 minus 9 is, the student wrote minus 5. They saw that if you had 4 and you took away 4 that you got to 0, but then they had another 5 to take away and that got them to minus 5. Then they looked at the tens place. 6 take away 7, so that they knew that there were the 6 that you took away and then one more, so that left them into negative in the tens place. And then 3 take away nothing, left them a positive 3 in the hundreds place. Then I strongly suspect that they started at 300 and they took away 10 to get 290. They took away 5 more to get to 285. I don't think that the student knows an algorithm. I'm really impressed that they know about negative numbers and they were able to handle the process one step at a time, just looking through each place value and putting in zeros to keep everything tidy. I don't see any mistakes. Now we move to problem number 2. And what I see here is that the student is attempting to apply the algorithm, but I strongly suspect that the student does not understand the algorithm. Let's start by writing the problem again, 364 minus 79. And so what we see is that we have 4, we want to take away 9, so they borrowed from the 6 and wrote down 5 and gave it to the 4 and said 14 minus 9 is 5. That's just fine. Now here's the problem we run into. If 5 take away 7, they knew to borrow from the 3 and turn that into a 2, but instead of giving the 10 tens in form, the 100 in terms of 10 tens to the 5 and make that 15, they crossed the 5 out and made that 4. And then on top of it all, they subtracted 4 from 7 to get the 3 instead of subtracting 7 from 14, which is what they should have been doing. So 235. So they made 2 mistakes. One was borrowing from the 3 and not giving it as a 10 tens to the 5, but just reducing the 5 again. And the other was subtracting the 4 from the 7 instead of the 7 from the 4. So I think this student knew the algorithm or had practiced the algorithm, but didn't really understand it. Just knew to cross things out and change numbers, but wasn't clear on borrowing and carrying in 2 different place values. And then when, after the borrow and carry and saw that this number was still smaller than that number, they just switched the order of subtraction. So now we have number 3, 364 minus 79. So this student, it appears to me, is applying the algorithm. They said 4 take away 9, 4 is too small, so they crossed out 6 and wrote the 5 and gave that 110 in the form of 10 ones to the 4 to make it 14. 14 minus 9 is 5, so we're good on that. Then they said, okay, 5 minus 7, 5 is too small, so they borrowed from the hundreds. 100 is in the form of 10 tens, so they added it to the 5 to make 15, turned that 300 into 200. So 15 minus 7 is 8, and 2 minus 0 is 2. So yes, this student appears to know the algorithm, applied it properly in all the different parts, and probably understands what's going on. It's not clear if the student really knows the underlying process of why it works the way that it does, but it's obvious that the student knows how to apply it properly. So this is number 4, and this is interesting because you see numbers being placed up here, and numbers being crossed off, but the 7 went to 8 instead of down to 6, which is what you would expect if the student was applying the standard algorithm. Now, what's interesting to me is that I really recognize this process, because even though I was taught and raised on the standard United States subtraction algorithm, when I was an adult, I met a woman who was from France, and she taught me the French style of subtraction, which I like much better than the US standard. And this is pretty much the French style. The notation is a little different than the French style, but it works. What this student sees is that 4 minus 9, 4 is smaller than 9, so we want to make it bigger. This student added 10 ones to the upper number, but instead of borrowing it, he or she also then kept the balance in the problem by adding 110 to the lower number. So you see this is 364 plus 10 in the form of 10 ones, and this is 79 plus 10 in the form of 110. So they said, okay, I'll add 10 ones here and 110 there. So it's like they took these base blocks, they put 10 singles with this bunch, and they put 1 long with this bunch. Now they have 14 minus 9 is 5. Okay, now they do 6 minus 8, and they said, okay, well, we have to do that again. The 6 is smaller than the 8. So they add 10 tens here to the 6 to make it 16. There's no digit over here, but they put the little 1 there. And that little 1 is adding 10 tens in the form of 100. So now we have 16 minus 8 is 8, and 3 minus 1 is 2. And we see that the answer is correct. So I don't think the student knows the algorithm, but the student does have a very strong grasp on how to handle it. If I were to work this problem using the French method with their notation, it would be the same sort of thing, only the way that I learned it was, you say 4 minus 9, 4 is too small, so I add 10 ones, and I add 110. So when I put a 1 up there, it's the same place value, but 10 of them. When I put a 1 down below, it's the same place value, but just 1 of them. So 14 minus 9 is 5. 6 minus 8, so I make that 16, and I add in 1 there. So 16 minus 8 is 8, and 3 minus 1 is 2. And what I really like about this method is how easy it is to check your work. 5 plus 9 is 14. 8 plus 7 is 15 plus 1 is 16. 2 plus 1 is 3. And I know that I did it right. So here is problem number 5. And what I see here is that the student has probably been exposed to the algorithm, but doesn't remember it thoroughly and certainly doesn't understand it. And what I'm seeing is that the student says, well, I know 4 take away 9, the 4 is too small, so I need to make it bigger by adding in 10 ones. And so he or she did that, but didn't balance off the whole problem by either borrowing a 10 from the 6 or adding a 10 to the 7. So that throws off the answer right there. So 14 minus 9 is 5. And then the same thing here. Oh, 6 minus 7, I need to give another 10, but no balancing off, saying, okay, 10 tens needs to be balanced off with 100. So then we got 16 minus 7 is 9, and 3 minus 0 is 3. So the student had a vague understanding of the carry part, or that you need to make the smaller number bigger by adding in 10 of them, but not understanding the need for balancing the whole problem. So now we do number 6, which is the one where the student wrote words to describe what it is that they're doing. So I started by writing the problem down, and then as I go through the wording, I'll write down the calculations that I'm seeing. The student says, first I take the 70 from the 360. So this person says, let's look at 364 is just 360, and we're subtracting off 70. And they say, I'm taking 70 from the 60, and that's 290. So they take away 60 of the 70s to get 300, and another 10 to get 290. So they took care of removing the 770 or 7 longs or 7 tens from the whole thing. And then they say, then I put the 4 back. So that's this 4. They took it away to get 360 and just deal with the tens places. And so now they put it back. So now we're at 294. And it says, then I take 9 away. So they need to take away that 9. And they say, well, okay, 9 is really 4 plus 5. So if I take away the 4, I'm back to 290. So that's what they say. It's 294. Then I take the 9 away, 4 first to 290, then 5. So then they take away the 5, and they get 285. So I don't think this person knows the algorithm at all, but I really believe that this person understands base blocks, is visualizing what's going on with the base blocks. They're seeing 36 longs, take away 7 longs, leaves 29 longs or 290. They put the 4 singles back, then they had to subtract off 9, so they took away 4 of the singles of the 9, and then said, okay, we have 5 singles left, and that gets to 285. So now this is number 7. It's another one where the student wrote their words down. And the student says, well, I know that's the same as 365 minus 80. So this person looks at 364 minus 79, and they said, you know, if I add 1 to each number, I get the same difference as 365 minus 80. So doing plus 1 to both numbers, all it's doing is moving both numbers up by 1 on the number line. But the distance between those two numbers is the same as the distance between the two moved numbers. Okay, so they said, all right, well, if I add 1, I get the same distance between them as if I subtract 365 or take 80 from 365. And then they say, and that's the same as 385 minus 100. So what they said was, well, look, if I move them up by 20 each, then I get 385 minus 100. And boy, that's really easy to do. It's easy to take away 100 from 385. So we know that the answer is 285. So this student, I don't think understands the algorithm or has been exposed to the algorithm, but is very comfortable with manipulating numbers on the number line and recognizing that the distances are the same as long as you move both numbers by the same amount each time. The distance between them is going to remain the same. And so they bumped it up, the lower number, they bumped up to 100 because that makes it so much easier to do the subtraction. So let's look at number 8. Why did the student write down their work this way? I think the student was working from left to right, starting with the hundreds place, and doing the subtraction each time and seeing what the result was as they worked their way across. So 300 minus nothing is just 300. And 60 minus 70 is negative 10. You take away all 6 of them, and then you have to take away 10 more. So they said 300 take away 10 more leaves 290. And then they said 4 take away 9. They said, well, if you take away 4 of them, you're at 0. So you have to take away another 5. 5 from 290 is 285. And since they had worked their way from left to right and ended up at the ones place, they knew that that final answer was the right one. So they crossed them off as they did the next calculation, and then they stopped crossing once they were done. So no, I don't think that they know the algorithm, but I think they're quite comfortable with takeaway. I don't know whether they were thinking in negative numbers or just recognizing, say for base blocks, regrouping as needed, regrouping one of the 3 flats into 10 longs, and then taking away what you need to take away in order to get your 290, and so on. For number 9, this student appears to have the same sort of technique as in number 8, just writing it down differently. Working from left to right, seeing that there are 300s and nothing taken away, so that's 300. They recognize that 6 take away 7 is minus 10, so they have some concept of negative numbers. So they wrote down the negative 10 instead of, like the person in the previous problem, doing it in their head. And so 300 take away the 290. And then 4 take away 9 leaves a minus 5, which they wrote down, and they did the subtraction. So no indication of knowing the algorithm, but a definite understanding of the process and how to handle with the negative numbers. For problem number 10, this is called the open number line method. And what you do is you are hopping along the number line, and the hops are determined by what appeals to you mathematically. If I look at this problem, then what I see is that the original problem was 417 minus 88. And I know this because we start here at 417, and the arrows of the hops, you have to tell the direction of the hops. You have to show that when you're doing this technique. The arrows are telling you to hop to the left, and first this person jumped 7 and then 80 and then 1. So you add all of those up, and the total amount of hopping is the 88. So that's telling you you're subtracting that from 417, and then the place that you end up is 329, and that's the answer. So this person, I don't think understands the algorithm or has been exposed to the algorithm, but they said, look, if I start at 417, if I subtract 7, that's really a convenient number to pick. That gets me to 410, and I don't have anything but 0 in the ones place. So then if I subtract 80, I can drop down, let's see, I can go 400, that's 10, and then to 330, that's another 70. So that gets me to 80 at 330. And then I've done 87 and I have to do 88, so I just do one more hop, and that gets me to 329, and that's the end. Now I want to explain this method because it is really convenient. It's so visual and it's so wonderful. This is how this person saw to do the subtraction. But different people will see it different ways, and you can do it in different types of jumps. So for example, if I were to erase this and start on the number line again, I would do it this way. I would say, okay, 417 subtract 88. Well, I liked that subtract 7 because that got me to 410. But let's say that I'm not good at subtracting 80 from 410. Maybe I'm not comfortable with that. So why don't I subtract 10 and get myself to 400. Now I need to subtract 70. I can either subtract 70 if I'm comfortable with that, and say subtract 70, which takes me to 330. Or if you're not comfortable with that, you might want to jump by 50 to get to 350, and then 20 or 2 tens to get to 330. What's important is that these numbers add up to the number that you're subtracting. So now we've done 70, 87. We need to take off one more. So that gets me to 329. And this open number line method is really handy because it allows people to work with their strengths. If they're comfortable in seeing from 410 to 330 in one jump, that's great. If they're not, they can take smaller jumps along the way to work with what they're comfortable with. The one thing I would caution you on in using this, the number line method, is that if you feel very confident in your subtraction, you might just jump once or twice, and that's not really demonstrating the skill like someone who doesn't know the algorithm or doesn't know their subtraction numbers really well in their head. That doesn't show what a student learning subtraction would be doing. So don't get too fast here. Look at the logic and say, gee, it's best to get rid of that 7 in the ones place. That's great. And then jumping in a way to make it easy. That's the whole point of the open number line method, is to make your jumps easy. So don't go too quickly. Think like someone who isn't that confident in their subtraction.